This talk is for you if you've been doing double integrals, but you've been struggling. You keep getting confused, making mistakes. I'm going to show you a way to do double integrals that I believe is better than the way that most of you have learned. If you've only ever done single integrals, you will be able to follow along, but you should be aware that I will be skipping some details. This is not intended to be a complete introduction to double integrals. So here we have an example. There's a double integral. There's our domain. Actually, I'm going to show you 3 ways to do double integrals. First, I'll show you this better way. Then I'll go back and I'll do the same integral again, the standard way. I'll show you that so you can compare and contrast to my better way and maybe get some insight into where you were going wrong. And then the third way I'll do it is what I call the quick way, which is essentially a sloppy version of the second way. The quick way is how most people actually do this, and there are pros and cons to that. So let's start out doing it, number 1, the best way. When you look at this, you should see that this double integral is an integral inside of an integral. You should think of the integral symbols and the differentials as functioning like brackets. So inner goes with inner, outer goes with outer. Let's take this double integral and let's break it up into 2 single integrals the following way. I'm going to give this outer integral a name, and I'll call that A. A is for answer. That is what we're looking for. We're trying to find the answer. The inner integral I'll give a name, and I'll call that B. For lack of a better name, B stands for something other than A. So the B integral is the one we will do first, and B equals this. And when we're finished doing the B integral, we will solve the A integral, which looks like this. So we've taken this double integral and turned it into 2 single integrals, which you should already know how to do. So this first single integral should be pretty straightforward, but there is one twist that makes it different from a regular old single integral, and that is that we actually have 2 different variables here, x and y. What do you do in that situation? Well, this dy differential tells you what to do. The dy is saying, for our purposes in this integral, y is the variable, not x. X will be the variable over here, but for now, we're going to ignore the x. Well, we're just going to think of the x as being like a constant. The y is going to behave like a variable, and you'll integrate that in the usual way, and then the x will just come along for the ride just like a number would, like the number 3 or something like that. So we want to find the antiderivative of y, and that's easy enough. It's 1/2 y squared. So we will get 1/2, don't forget the x, there's a y squared evaluated from 0 to 3. So when we substitute, we will get the following. 1/2 x times 3 squared minus 1/2 x times 0 squared. Now I think you can pretty easily see what the answer is going to be. I'm going to recommend that you don't actually do double integrals this way most of the time. This is exactly what this is telling you to do, but there's a better alternative. I'm going to write it this way. I'm going to keep the 1/2 x separate, and I'm going to put those together. And it may not look like that helped me very much in this integral, and it didn't, but we're going to do a similar thing over here, and you're going to see that it can sometimes actually save you a lot of work. So there's 9, there's a 1/2 x, there's the answer, b equals 9/2 x. So we put that over here. 9/2 x dx. And that's just a plain old single integral, like you should have done a million times before. So we will get the antiderivative of x will be 1/2 x squared. So how about a 9/4 x squared evaluated from 1 to 2? So we will get 9/4 times 2 squared minus 9/4 times 1 squared. So 2 squared is 4. 4 times 9 fourths. The 4's cancel and we get a 9. And then over here we've got a 9 fourths. So you can see that we're running out of space and we still have 2 more steps to do. We have to get a common denominator and then put the 2 fractions together. It's very common to get bogged down in tedious details like this when doing double integrals. Some of that is unavoidable, but we can save ourselves some trouble if we don't do the thing that I just told you not to do. I'm going to change this back to how I did over here, and you will see that it's suddenly much easier. 2 squared is 4. 4 minus 1 is 3. 3 times 9 is 27. And there's your answer. 27 fourths. The essence of this method is these 2 labels, A and B. They help you be nice and clear and tidy about what you're doing and make it easy to avoid mistakes. Now let's do this again using the standard method. And I think maybe you will see where some of your troubles came from. In the standard method, we do not separate into 2 separate integrals. We just simply dive in and start doing it. All the mathematical stuff will be exactly the same as before, but it will look a little different. So here's how it goes. We're going to start with the b integral, of course, but we still have this a integral stuff here, so we need to deal with that. So we're going to integrate this y dy, and we'll get the 1/2 xy squared, evaluated from 0 to 3, just like before. And maybe you should put some brackets around that. Maybe not, to keep it clear. So then we still have integral from 1 to 2. We integrate this. Of course, we get 1/2 x times 3 squared minus 0 squared. And then we go again. And we're going to have 9/2 x dx. And then the rest of it is exactly the same as before, so I will speed it up. The problem with this method is that you are required to distract yourself. Every step of the way, as you work through the b integral and do the math here and here and here, you have to keep writing down the a integral stuff. You're not doing anything with the a integral stuff, it's just there, but you have to keep writing it in order to make sure that everything is equal and makes sense. So you literally have to keep diverting your attention back and forth from the a to the b to the a to the b, the a to the b, and you can imagine how confusing that can get. It's very easy to get things backwards. You can get the integrals backwards, you can get the x and the y backwards, you can get the differentials backwards. I don't even want to think about it. And of course, it would be much harder for you to follow along if you had not already seen me do it the other way. In fact, it would be hard for me to even talk to you about this if I had not already defined the a and the b integrals. There's the b and there's the a. What would I call it if I hadn't come up with those names? So my advice is, don't do this. So what should you do? Well, you can do it the first way, or you can consider doing it the third way. The third way is essentially a sloppy version of the second way. Here's what I'm going to do. I'm going to start doing the b integral like I did before, but I'm just going to ignore the a integral stuff for starters. So I'll do my 1/2 xy squared from 0 to 3 equals 1/2 x 3 squared minus 0 squared equals 9/2 x. But then at this step, I will bring the a integral stuff back into it and finish it off. And once again, it's just like before, so I will do it at double speed. This is the way many people do it. There is a problem with this. It is technically wrong because this is not equal to this. This is equal to this, but then this is not equal to that. Now, obviously, we know we did it right. We know that we have the right answer. In our minds, it was crystal clear what we were doing, but we left out this a integral stuff until we actually needed it. Your teacher may or may not tolerate you doing it this way. And if your teacher or professor does, then that's great. And if not, then you're going to have to do something other than this if you're turning in your work to be graded. So you have a couple of options there. You could either do it the first way. You could do it the second way, but I don't recommend that. Or you could be kind of sneaky and do it this third way, but then fudge things a little bit, like this. You can actually go back after the fact and add in the a integral stuff. Don't be distracted by the a integral putting it in line by line. Just ignore it until you're done with all that, and then it'll be easy to put it back. So if you turn in something that looks like this, no one's ever going to know that you did it a different way. If you enjoyed this, please like and subscribe. And by the way, if you are interested in being tutored online by me personally, I am available. You can find out more information at my website, alternaprof.com, or in the About page for this channel. Thank you very much.